James Webb Space Telescope has been successfully deployed in space at the second Lagrange point. The biggest and most powerful $10 billion space telescope was launched by NASA some days ago. Using this, you can time travel. It is not possible to go back into the time, but with this you can get a glimpse of history. And I am not talking about history made in last 5 or 10 years. Literally millions and billions of years history can be looked at using this telescope. More specifically 13 billion years into the past. The universe began with the Big Bang 13.8 billion years ago. And this telescope can look till 13 billion years ago, about 0.8 billion years after the universe began. But how it can possible? Come in today's video, let's understand this. The most special thing about this telescope is that it has been designed mainly to detect infrared light. When you look at the sky with a normal telescope, you see the wavelengths of visible lights, the light that you can see with your naked eye. Do you remember studying about electromagnetic spectrum in school? Electromagnetic waves in a particular ranges, it includes X-rays, UV rays, radio waves, microwaves, and in there is a small range of visible light, the light that we can see with our naked eyes. The range of visible light is between blue color and red color, and red has the biggest wavelength. And as you know, with electromagnetic waves, the bigger the wavelength, the easier to pass through any object or obstacle, like the radio waves, the radio that you listen to. The wavelengths of radio waves may span more than kilometers. For this reason, you can listen to the radio waves that pass through buildings even. The wavelengths of infrared are bigger than red color, but we cannot see infrared with our naked eyes. The advantage of using a telescope for looking at infrared can be seen in this photo. The photo on the left was taken by the Hubble Space Telescope. You can see the space dust and clouds of gases in it. But infrared wavelengths can pass through the dust and clouds, and we will be able to see what lies behind this. This picture on the right is what we imagine we would be able to see with the James Webb telescope. We will get more high quality HD picture. The infrared word comes from Latin. Infra means below, so infrared means below red, because its frequency lies below the red, and frequency is inversely proportional to wavelength. Anything that radiates heat emits infrared waves. Humans, animals, the sun, fire, each of these emits infrared waves. That's why in night goggles, you would have seen soldiers use night goggles often. Through the night vision goggles, you get a view like this. Since the telescope will look at stars and galaxies of stars and planets, all of which radiates heat, it will be possible to capture and look at the infrared waves. The other advantages of infrared is that when a telescope looks at stars at such a distance, stars that are billions of kilometers far from us, when the light from those stars reaches the telescope, the light has traveled such a distance that by the time it reaches here, and as we know the universe is slowly expanding, the wavelength of the light gets stretched, the wavelength gets elongated. This phenomena is known as redshift. With telescope, the bigger the mirror they have, the more light they would be able to capture, and the resolution of the image that we get will be that much higher. The mirror of Hubble Space Telescope was this size, and you have the mirror of James Webb Space Telescope beside it. James Webb Space Telescope entire mirror is plated with 24 karat gold, because gold is the best at reflecting red light. Because of gold, the reflectiveness of this mirror is 98%. This telescope has 18 hexagonally shaped primary mirror to function as a single 6.5 meter mirror. There is a problem here. Everything that radiates heat will emit infrared waves. When the telescope will start working, the telescope will radiate some heat too. It will interfere with the waves coming from the galaxies. We could not be able to get good high quality pictures. So that James Webb Space Telescope will work only at the cold temperatures of minus 223 degrees Celsius. But it is possible because it is very cold in space unless there is sunlight. To avoid the problem, a sun shield has been installed on the James Webb Space Telescope. This sun shield is in the shape of a kite and is as big as a tennis court, so the telescope could remain protected from the sun. For this, a very special material, krypton, has been used. The krypton was artificially created. This sun shield comes with 5 layers of krypton. There is a vacuum gap between each layers so that its effectiveness could be increased. Apart from this, each layer has an aluminum coating on it, and the 2 layers closest to the sun have a coating of doped silicon. The Hubble Space Telescope is close to the Earth and orbits around it, but this was deployed 1.5 million kilometers away from the Earth, at the point known as the L2 point. L stands for Lagrange point. This point is on the other side of Sun because obviously it is important to block the heat and light of the Sun as much as possible for the better functioning of this telescope. L2 point is special because it keeps revolving with Earth, so the Sun will be hidden throughout the revolution. The Earth's shadow will keep the Sun hidden. The scientists have pinned their hopes that using this they would be able to study how did stars and galaxies form after the Big Bang. With this telescope you can look 13 billion years into the past. The Hubble Space Telescope could look at only 12.8 billion years into the past, when stars began to form first. Light takes some time to travel the distance, and by the time the light reaches from one place to the other, the stars and galaxies that are millions of light years away from us, when we look at them through the telescope, we are actually seeing them as they are millions of years ago. The universe is so huge that there are stars that are 13 billion light years away from us. By the time their light reaches Earth, 13 billion years would have elapsed, and what we get to see today are the events of 13 billion years ago. This way we can get a glimpse of history. With this logic, the James Webb Space Telescope will work. It will be also interesting to see the new planets that James Webb Space Telescope discovers. Can it find a planet with Earth-like conditions where life can be possibly found? Time will tell it. I hope you would like this video. Subscribe for more video like this.